So let's wrap up this discussion of the fork join pool and the common fork join pool by summarizing some of the benefits that come from using it. So there's several benefits of using a fork join pool relative to other Java thread pools that come out of the box. Now, we haven't talked a lot about these other pools. They're covered in a different class, but just to summarize them very quickly, there's a fixed size thread pool where you say, I want to have 10 threads or 8 threads or however many threads, and that's what you got. There's also something that's called a cached thread pool, or also known as a variable size thread pool. What happens there is whenever someone wants to submit something or execute a task with the cached thread pool, the cached thread pool first checks to see, are there any threads I have under my control that are currently not doing anything? And if so, I'll hand the work off to that thread, one of those threads that's ready to do work because it's otherwise idle. Or else, I will create a new thread and then run the computation on that. And after that thread is done with the computation, I will keep it around for up to 60 seconds before I terminate it. So that's what a variable size thread pool is. It can kind of grow and shrink as the workload increases or as the workload goes away. The common fork join pool, or just a given fork join thread pool, as we saw, has some other cool things that it provides. In particular, it has locality of reference because it will push work onto each worker thread's deck using a LIFO protocol. So last in, first out. So whatever it's going to work on next comes from what was just pushed on when it doesn't have anything else to push. And therefore, we get locality of reference and improved cache performance. That's one of the benefits we get from using the fork join pool versus the other pools. We also get recursive decomposition. So typically, the way this works, as we've seen, is we take a big chunk of data and we split it up successively until we have lots of little chunks. And then the larger chunks are pushed onto the deck before the smaller chunks. And therefore, when work is going to be stolen, it's stolen from the end of the deck, so you get a bigger chunk at the end. That, of course, is the next benefit, is work stealing. Remember, the whole purpose of work stealing is to maximize core utilization. By having idle worker threads that don't have anything in their deck, they're not playing with a full deck, or any deck for that matter, they will steal from the tail of busier threads' decks. So you can keep things humming along. So that's essentially some of the benefits. Let's talk about the benefits of the common fork join pool. So one of the main benefits here is to optimize resource utilization, because the common fork join pool is aware of all the cores that are being used globally within a process. We've talked about before, it always has one less than the total number of cores of threads by default, and that's because the calling thread pitches in and does some work as well. So very much like how Professor X from the X-Men, which should be the X-People because they're not all men, but whatever, he has this thing called Cerebro, where he puts the helmet on and he can see everything throughout the world. That's kind of the way the common fork join pool works, except it's not quite as smart as Professor X. This particular way of doing things enables scalable and efficient work stealing, because it gives us a larger set of work to steal from. And remember, the way that stealing works in thread pools is you can only steal from your pool. You can't steal from other pools. So by putting everything into a common pool, it makes a lot more things to steal, which is good. In this particular case, stealing is good. You do not go to jail for stealing in the work pools, the worker threads in the fork join pool, common fork join pool. The other nice thing we get, and this again is true for other pools besides the common pool, but it's particularly useful for the common pool because we often use that for things like parallel streams, is auto-scaling via the managed blocker interface, which will temporarily add worker threads to the common pool as we saw before, so it can be expanded and contracted flexibly at runtime. And another nice thing about the common fork join pool is it can be used without explicitly creating a new instance. So when you start up any Java program past Java 8, there is a common fork join pool that exists. It's essentially a singleton, although it's not implemented quite as a singleton, but it's effectively a singleton in the sense that there's only one instance, and it's used to coordinate the processing of all the different threads that run in that context, and they can therefore be stolen and so on and so forth. So that's the end of the summary of the common ForkJoinPool and ForkJoinPool benefits.